Here is another example of a function using pointers. I want to create a function that adds 3 to an integer. Let me write the main function so that you can understand what I want to do. First, I create an integer, a, and I want something that resembles like this. Add 3, and then I put a as an argument of add 3, and I want this function to add 3 to what I put as an argument, and then I print. Printf inside main value of a %d \n. So how do you do that without integers to see that it is not working? Well, and the thing is here, I want a function that doesn't return anything. As you can see, I just call the function and I don't get the result value. Otherwise, it should be like result equal something, but I don't use the returning of the function, so it's void. The name is add3, and here is an integer that I put as an argument. So when I define the function void add3, I can call the parameters the same, a, and inside, of course, I do a equals a plus 3, like this. All right, doesn't return anything, so it's pretty simple. It's only one instruction. And just to check, I will do a printf here. Inside add3, the value of a is %d \n, and we will try to compile and execute this program. So I hit compile and then execute line by line. Of course, I have the show memory here to see what's happening in memory. So I create a, I call add3, and I copy the value of a within the parameter of add3a. So in the memory here, I have two a's. I have the a of the main function, 5, and I have the a of the add3 function. And indeed, inside the add3 function, a equals a plus 3 will modify the a of the add3 function, but not the a of the main function. So the first printf inside the add3 function will print the value of a 8. But when we go back inside the main function, well, the original a was not modified indeed. So the printf prints inside main value of a is still 5. It was not modified. And that's when you want to use pointers. So instead of using the value of a directly, we will use the address of a. So here, instead of integer, I need a pointer, I need an address. So int star, meaning that we will get as a parameter an address, and at this address there is an integer. When we call the function, we don't put the value of a, but we put the address of the variable a. And here, when we define the function, well, we need a star here to say that it's not an integer, but it's a pointer to an integer. And within the instructions, we will not modify the address, but what is pointed by the address. So star a equals star a by star a plus 3. So here we will modify what is pointed by the address, meaning that we will modify the original a here. Let's compile and execute to see what's happening. Oop, there is a small warning here. Format specifies type int, but the argument has type int star. Indeed, this printf here, I use %d. %d is for integers, but here a is not an integer anymore. It's an int star. It's a pointer to an integer. It's an address. So we don't print an address using %d, but we want to print what is pointed by this address. So we will dereference a and say, all right, we want to print what is pointed by I. So here I add a star to say, well, it's not the address that we want to print, but it's what what is pointed by the address. All right, should be okay now if we compile. All right, and we will execute step by step to see what's happening. So first we create the A in the main function, and then we call the add3 with the address of A. So the A here of add3 is an address. It is indeed FFFC, which is the address of A. So when we do star A equals star A plus 3, it means what is at the address FFFC equals what is at the address FFFC plus 3. So indeed, when we execute that, we modify the original A in the main function. And the printf, of course, will print the original value of A, and the second printf also. So here is how you use functions using pointers. Now, try it by yourself and try to add a function that multiplies by 3, for example. Keep this code here and just try to complete it so that you multiply by 3 just after adding 3. Try it yourself now.